In this video, I'm going to talk about exponent laws. When we talk about exponent, we should not forget that there must always be a corresponding base. This number a is usually called a base, while this x is called an exponent. For example, when we do 2 to the power 5, then 2 is the base and 5 is the exponent. 2 to the power 5 is actually meaning 2 self-multiplied 5 times. This should not be mixed up with 5 times 2. 5 times 2 is actually representing 2 self-added 5 times. The first number is 32, while the second number is 10, and they're totally different. Our topic today, exponent laws, refer to some properties when we manipulate exponents that share the same base. If the bases are different while the exponents are the same, then we refer to that as distribution of exponents, which are discussed in another video whose link is posted at the top right corner. There are 4 exponent laws in total, but I would like to start by stressing that there is no exponent law that tackles adding or subtracting 2 exponents with the same base. The first exponent law is about multiplying 2 exponential numbers with the same base. We can combine them into one, where the exponent is given by x plus y. The second exponent law is dealing with dividing 2 exponential numbers with the same base. And we can combine them into one exponent, x minus y. The third exponent law deals with the situation when we have a to the power x and then raise it to the power y. We can express this as simply a to the power x times y in the exponent. Now, we have seen x plus y, x minus y, and x times y in the exponent. What about a to the power x over y? The fourth exponent law tells us this will become a to the power x and then take the y root. So far, we are actually a little careless. To make things more precise, we should specify the conditions on our variables a, x, and y in each case. In all 4 exponent laws, we are going to assume that a is always positive. As for x and y, they can be any real numbers for 1, 2, and 3. However, we are going to require that y is a positive integer in the 4th exponent law. How do I memorize all of them? I use the order of operations. What do I mean? Well, we should all remember that at the bottom of order of operations, we have addition and subtraction. Above that, we have multiplication and division. And above that, we have power and root. Let's take a look at the first exponent law. On the left-hand side, we have a multiplication operator at the base level, which is a lower level than the exponent level. If we want to change the multiplication operator to a suitable operator at the exponent level, which one should we use? Well, we have already raised our level from the base to the exponent. In order to balance things out, we should use a lower operator than the multiplication. So we will choose addition. Using the same logic, on this side, we have division operator at the base level. So we will choose a lower operator than division at the exponent level here, which is subtraction. Here, we are doing power in the base level. When we raise it to the exponent level, we should use a lower operator than power, which is multiplication. Here, we do root at the base level. When we raise it to the exponent level, we should use a lower operator than the root, which is division. Now that we have seen all four exponent laws, let's try to take a look at why they work. For example, a squared times a cubed can be rewritten as a times a multiplied to a times a times a. Altogether, there are 5 a's self-multiplied to each other, and therefore we can rewrite that as a to the power 5. Where does the 5 come from? It's exactly coming from 2 plus 3. And this illustrates the first exponent law when x and y are positive integers. How about the second exponent law? Let's try a to the power 3 divided by a to the power 2. The numerator can be rewritten as a times a times a, while the denominator can be rewritten as a times a. 2 a's from the numerator can cancel with 2 a's in the denominator, and we are left with one single a from the numerator, or we can understand that as a to the power 1. Where does the 1 come from? It's coming from 3 minus 2, because we are removing 2 a's from the numerator. As for the third exponent law, we can understand it by writing out a squared and then raise it to power 3. A squared is just a times a, while this power 3 means that this group has to be self-repeated 3 times. So we have a times a times a times a multiplied together. Altogether, there are 6 a's, so we have a to the power 6. Where does the 6 come from? It's coming from 3 times 2, 3 groups of 2 a's each time. To understand the fourth identity, we should recall what root truly means. Root is actually helping us to solve an equation. For example, if we say a squared and then take the cube root, what this does is this is a solution to x to the power 3 equals to a squared. If you plug this into x and then cube it, you will get a squared. That's what cube root truly means. Now, let's try to substitute x equal to a to the power 2 over 3 and see what will happen. A to the power 2 over 3, when you raise to the power 3, according to the third exponent law, we will get a to the power 2 over 3 times 3, which can be simplified in the exponent into just a simple 2. Oh, wait a second. A to the power 2/3 now satisfies this equation, and therefore the conclusion is the cube root of a squared is exactly the same as a to the power 2 over 3 because they both solve this particular equation. Actually, there are still some hidden technical details. For instance, we have to argue that x cubed is an injective function over the reals. However, for our purpose in this video, we are going to skip over this detail. Lastly, I'm going to use the exponent laws to clarify a common error that I see among students. Many people look at a to the power -2 and thought that that is equal to negative of a squared. But it is completely wrong. a to the power negative 2 can be rewritten as, for example, a to the power 3 minus 5, because 3 minus 5 is negative 2. According to the second exponent law, we can rewrite it backwards as a to the power 3 over a to the power 5. A to the power 3 is simply a times a times a in the numerator, while a to the power 5 is a times a times a times a times a in the denominator. After cancelling out 3 a's each from the numerator and denominator, we will get 1 over a times a, or 1 over a squared. That is what a to the power negative 2 is. It is the reciprocal of a squared, instead of negative a squared. We can also use the similar method to see why a to the power 0 is 1. A to the power 0 can be rewritten, for example, as a to the power 2 minus 2. According to the second exponent law, we will have a squared divided by a squared, and this is clearly going to simplify into 1. Thank you very much for watching this video. If you like this video, please subscribe to our channel and we will learn more fun math together. Thank you.